Welcome to my channel on chemistry lessons. Make sure you like and subscribe. So this is aimed at BTEC Applied Science Unit 5 Chemistry, but it is relevant for other A-level specifications for the free radical substitution in alkanes. So in terms of the BTEC Applied Science specification, it's Learning Aim A2 in Unit 5. And it's down the bottom here, the free radical substitution in alkenes. Now, if you haven't looked at the introduction to alkanes video, I suggest you do that before you go any further with this video. Let's start with some key terms then. So the term halogenation means the adding of a halogen to an alkane. So this is the halogenation of alkanes, and it's adding a group 7 atom to the alkane. The term free radical is given to something or a species that has an unpaired electron. And we usually see that or represent it as a dot. So Cl dot, that would represent a chlorine free radical. Homolytic fission. This is when the covalent bond breaks to form two free radicals. For example, the covalent bond between two chlorines. If that bond breaks so that one electron goes to one chlorine and the other electron goes to the other chlorine, you end up with two chlorine free radicals. That's homolytic fission. We're going to use the term reaction mechanism, and the mechanism of a reaction just shows the step-by-step sequence that lead to the overall chemical change. So in other words, chemical reactions don't just happen instantly as one step. It's usually over a series of sequences or steps, and that's known as the reaction mechanism. So let's look at the overall reaction to start with then. So this is known as the free radical substitution. That's because free radicals are involved and it's a substitution reaction. What we're going to be doing is one of the hydrogens, and it can be any of the hydrogens in the alkane, I've just circled one of them there. One of the halogens will swap with one of the hydrogens. So our product, in this case, that one hydrogen that I've circled is going to be substituted, which means swapped, with one of the halogens, leaving behind HBr. So what's happened in this chemical reaction is a molecule of an alkane has reacted with a halogen, in this case Br2. Halogen is anything from group 7. This could have been Cl2, it could have been I2. So it's a halogen, and one of the halogens in the Br2 has swapped places with the H. So now we have HBr as a product and our halo alkane as a product. In order to do that, we did need UV light. So this would be our overall equation here. It's one molecule of our alkane reacting with one diatomic molecule of the halogen, forming the halo alkane and HX, or the HBr in this case. So now we're going to look at the actual reaction mechanism instead of the overall equation. And as we've seen from earlier slides, the reaction mechanism is going to show us the step-by-step sequences that happen in that chemical reaction. And the free radical substitution in alkanes always takes place over 3 steps, or there's 3 sequences to it. So the first sequence, or the first step, is known as the initiation step. And this step requires UV light. And there's only one step in this section. So the halogen, I'm going to stick with bromine. So the initiation takes the halogen and turns it into 2 halogen free radicals. So we end up with Br2 makes 2 Br dot. And it's important to show this dot because I'm showing that it's a free radical. And UV light is needed, so we often write UV light above this arrow. UV light is needed to break that bond in the bromine. So what's actually happening here is that UV light is providing the energy for this bond to undergo homolytic fission. So that's what's actually happening. But we need to be aware of that equation. Br2 goes to 2Br dot. Now, if this was halogenation using chlorine, then all we'd simply do is have Cl2 going to 2Cl dot. So the second stage of the free radical substitution is known as the propagation stage. And this requires two steps. So what we need is we take our free radical from the previous step. So the free radical from the initiation is needed now. And this time it reacts with our alkane. Now I'm going to show a structural formula of ethane. So the free radical is going to react with the alkane. And what it does is it removes one of the hydrogens to become HBr. So that Br free radical removes one of the hydrogens. I'm going to remove the hydrogen on the first carbon, so that now becomes CH2, CH3. But what I must remember to do here is where I've just removed the hydrogen, that carbon becomes a free radical. So it's important here to recognise that in a propagation step, we have a free radical at the start with a non-free radical, and it forms a free radical and a non-free radical. And that's the first step of propagation. The second step of propagation requires this new free radical that we've just formed. So I'm just repeating this new free radical from here. This time it will react with the halogen and not the free radical. So it goes back to Br2. So it's reacting with Br2 here. And now what we do is we form our product. So the bromine now will be bonded to that carbon that was a free radical. So the bromine's now bonded to that carbon. And you can see the substitution is now complete. We've now substituted the hydrogen on that carbon for the halogen. But it also leaves us with another free radical. So again, we can recognize it as a propagation because we've got one free radical in the reactants with a non-free radical, producing a free radical in the products and a non-free radical. So there's always one free radical on either side in a propagation step. That's our two propagation steps there. And the final stage of the mechanism is a termination step. This is where the reaction can be terminated, which means finished. And it's whenever two free radicals come together to form a non-free radical. So there are actually several different possibilities here. The one that I like best would be to take the free radical that we've seen in the previous slide with the halogen free radical. They will come together to form our product. So all that's happening is the free radical is joining. So this electron and this electron are pairing up to make a covalent bond between that C and Br. So that would be classed as a termination step. Another possibility would be to take a Br free radical with a Br free radical, and they can come together to form Br2. That's also classed as a termination step. And again, there's nothing stopping me from taking this free radical and reacting it with another identical free radical. And this is going to be slightly more complicated to draw, but it's going to be CH3 and a CH2 bonded to the CH2 and a CH3. That's slightly more complicated to get your head around. But what's happening is this electron and this electron are forming a covalent bond. So we're literally joining those two CH2s together in the middle here. So we're going to look at a couple of past exam questions now, and these were from Unit 5 BTEC Applied Science. So I suggest you pause the video, you have a go at these questions yourself, and when you're ready to hear the answers, unpause the video. So the first question is asking us to complete this sentence. A free radical is a species with an unpaired electron. Part 2, what type of bond fission is shown in the initiation? That's homolytic fission. Part 3 is slightly complex. We've got to recognise that Y is used up in the second step. So Y has to be our alkane with a free radical. So it's the dot C4H9. Because what happens in that first initiation, in that first propagation step, this bromine free radical will remove the hydrogen, or one of the hydrogens, so it becomes HBr. And then what I've done is one of those hydrogens is now gone, so that's why it becomes C4H9. And we mustn't forget to draw that dot to show that that C4H9 is now a free radical. So Z, so in the second propagation step, this newly formed free radical Y reacts with another halogen, so Br2. And part 4, finally, the reaction ends with a termination step. Suggest what happens to the free radicals in a termination step. Well, two free radicals can come together. Well, in this case, it's bromine, so I'm going to go with bromine. So two bromine free radicals can come together to form bromine. So the two free radicals come together to form the halogen. Okay, so the second exam question then. So again, I'm going to suggest you pause the video and have a go at this one. And when you're ready to hear the answer, you unpause the video. Now this is probably your worst nightmare or the worst possible free radical question, a 6-mark question. But let's check the question. So we've been told here that chloromethane is produced when chlorine reacts with methane. So I'm just going to have a look at the overall equation. So methane is going to react with chlorine to make chloromethane. And I know that that's a substitution. So one of the chlorines substitutes with one of the H's. That's the overall equation. I know that we would need UV light to do that. And it's asking me to explain the 3 stages. So I'm actually just going to get straight in there and say the initiation is the first stage. Initiation is the first stage or the first step, and that requires the chlorine to become 2 chlorine free radicals with UV light. So that's the first stage. The second stage is the propagation steps. And again, I'm naming each stage. This requires 2 steps. It's going to be the chlorine free radical reacting with methane. So I'm being specific to the question. Don't just copy down the ones that you've done for revision. Make sure it matches the question. This question is the chlorination of methane. So the first step, the chlorine free radical will take one of the H's to become HCl. And I've now formed a chlorine free radical. Not a chlorine, a CH3 free radical, because I've taken off one of the H's. The second step for propagation is this newly formed CH3 free radical with the halogen to make our product ClCH3. You could put CH3Cl, it's correct, plus a chlorine free radical. So notice how the propagation steps, 1 free radical in the reactants and 1 free radical in the products. And the third and final is known as the termination. And I just need to give one example. I'll put 2 chlorine free radicals coming together to make a chlorine Cl2 molecule. That's going to get me all 6 marks. Hopefully you found this lesson useful. If you did, make sure you like, subscribe and comment.